Welcome. This session is on ensuring fiber optic system performance. The focus is on the proper handling of fiber interfaces with respect to inspection and cleaning. Typically, most people do not want to attend a fiber inspection and cleaning class. This slide gives many examples of why people need this training, so please take some time to see if any of these examples apply to you or your team. Fiber interface refers to terminated fibers with connectors on them such as SAM Charlie, Lima Charlie, MTP, MPO, and more. This can be a male connector such as a jumper or a female connector such as a patch panel or bulkhead. When people or companies move from metallic connectors to fiber optic connectors, it is common to see failure rates of 40, 45, 50% and higher at turnup. The telecom industry is used to metallic connectors which do not require inspection or cleaning. If we can have problems with our windshields, glasses, windows, and mirrors due to dirt, then it is certainly possible to have issues when the glass on a single mode fiber is about 1/10 the diameter of a human hair. Even when people are told to inspect or clean, it is commonly not done, and this session gives some data to show why both are required. Even people with years of fiber experience can have poor inspection and cleaning habits. In the upper left picture, entitled Picture 1, we see the white dot in the middle is a 9-micron single-mode core. We see the gray circle as a 125-micron cladding, and the white outer area is the ferrule. Here on the OTDR trace, connector 1 is represented by a low reflection and low loss. In the lower left, we see image 3, represented on the trace by a high reflection and a high loss. We see some dirt with only 2 tiny pieces touching the core. We can get a fiber this dirty just by dropping it on the ground, hitting the back of our hand or our finger, or touching it to our clothes. By getting this amount of dirt on the fiber, our back reflections get 30 times worse, or 30 dBs worse, which is 1,000 times worse, and we pick up 4.6 dBs extra loss. We say a UPC fiber has a flat cut. Notice in this picture that where the 2 fiber interfaces meet, there's actually a curve, bubble, or dome at the end of the fiber. This curve or dome is about 200 microns in diameter. I equate this to bowling balls. If we touch 2 bowling balls in the middle, they are guaranteed to touch in the middle. That is why this curve is here, to guarantee this 9-micron core touches this 9-micron core. When we click a SAM Charlie or Lima Charlie together, there's a force of 2.2 pounds. But when we put 2.2 pounds over a diameter that's 200 microns in diameter, that gives us thousands of PSI, and that could cause problems on fiber optic networks. On the left, we see a 9-micron core. We see some dirt. We see 3 big pieces of dirt, and notice they are all bigger than the core. They appear as shadows, so they look like they're 2-dimensional. If we take a look at that connector from the side, these 3 big pieces of dirt could actually be 3-dimensional, such as floor dirt or road dirt. Now they are effectively serving as microscopic pebbles. When we connect this connector without removing that dirt, the high pressure can take these big pieces of dirt and explode them into little dirt. Here is the first connection with no cleaning. We see the big dirt explode into little. Here's a second connection. Here is a third connection. We pick up this piece of dirt or lint at 2 o'clock, and here is the 4th connection. Now the big pieces of dirt have exploded in the little dirts, and the little dirts can actually get stuck, embedded in the glass, or they can cause chips or scratches in the same way a pebble can damage a windshield. Here is another visual representation to show this effect. If we touch the end of a jumper with the inside of our hands, just smack that jumper for a tiny amount of time, almost all of us will apply a generous helping of skin oil onto the clean fiber. Take this filthy fiber and plug it into another one, and the perfectly clean fiber now becomes filthy with oil. And notice that there is a ring on the fiber. Here's our 125 micron core, And out here we see a ring at 200 microns. Because of the high pressures involved, the liquid near the outside was smushed out here. The liquid in the inside has nowhere to go. So this is another visual representation to show there's huge pressure involved when a fiber is connected. If we plug in clean, there is a nook and cranny formed where the two domes or curves meet. As the fans blow hot air out of the electronics and the HVAC system blows cool air across to suck it out, dirt gets caught in this nook and cranny. When the fiber is disconnected, we'll see this ring, clean it off, plug it back in, and it's good for 25 years. Also note that if we connect clean, no dirt is going to get inside of this coffee ring. So if you plug in clean, it stays clean. Here we have a couple of pieces of dirt. So if you plug in dirty, it's going to stay dirty, and this doesn't lie. If you plug in clean, it stays clean. If you plug in dirty, it's going to be dirty when you disconnect it. Here's an example of a 10 gig transmitter that came to our factory for repair twice. Our technician cleaned it twice and sent it back. This was supposed to shoot 10 gigabit Ethernet traffic 30 miles, and it can go 3 feet. This company was not aware of proper inspection and cleaning practices. If a tester can't shoot 3 feet, we knew they were having network problems. They just weren't aware of it. The OBI says inspect before you connect, or as we call it, IBYC. Inspect the fiber. If it's clean, plug it in. If it's dirty, clean it. If that doesn't work, you can try a wet clean. If a wet clean is used, all the liquid or solvent must be totally dried off. If it's permanent damage and the connection fails, then that fiber needs to be replaced. Note that IBYC applies to both sides of the connector. Here we see a jumper being inspected, and on the right side we see the bulkhead being inspected. If we're going to do an OTDR test, the OTDR has glass. The launch cable has glass at both ends, so there's 2 pieces of glass, and then the fiber network itself has glass. So we have 4 pieces of glass just to get to distance 0. Testers need to be clean to work, and of course the network needs to be clean to work properly as well. What we are supposed to do is on the left side, a proactive stance. We inspect the fiber, see it's dirty, clean it, plug it back in, and it's good for 25 years. What we tend to do is use improper habits, find out that there's problems later, troubleshoot, see a dirty connector, clean it, but then we have permanent damage, where it's too late, damage has been suffered, the network has been impacted, and we have to waste time and money to replace stuff. Here's our summary. It is common for dirty connectors to account for 75% or more of the problems caused on optical networks. Clean connectors cause less network troubleshooting and ensure the optical network is ready to support future applications. Proper IBYC habits require training, equipment, and practice. There have been training sessions where during the class, attendees will plug a jumper directly into a $100,000 tester without inspecting or cleaning the tester or the jumpers. Damaged test equipment, jumpers, patch panels, and network elements are not repaired under warranty. Preventing damage can be done cheaply and in a short amount of time. If you or any of members on your team were not aware of all of this information in this short video, please contact your local VIB rep to inquire about on-site or web training. Thank you.